the number of diamonds or jokers. Well, of course, this is going to be the same thing as the number of diamonds plus the number of jokers minus the number of diamonds and jokers. Well, if we go ahead and just take a look at what's happening here, we can very easily see that diamonds, which is here, and jokers, which are here, are disjoint since they're mutually exclusive. In other words, there's no intersection. And so what we can say then is that this right over here is really 0. So what that means then is that we can simplify this particular equation to look like this. Maybe I should just put it there and just to know that we're being consistent. And J. Okay, so notice that if we go ahead now and again do the same process here, what I have here is this is going to be the probability of D union J is equal to the probability of D plus the probability of J. And of course, this is going to be true only if your two sets have no intersection, or in other words, they're disjoint, or we can also say that they are mutually exclusive events. Okay? So there you go. If we know then that there's no intersection, we can just eliminate this part and we can go ahead and use just that part. But if there is intersection, we need to go ahead and account for that way. Now, the other thing that we need to go ahead and take a look at is simple probability and conditional probability. Now, of course, we've already talked about what is the probability of a king, and we said that that's very simply the number of kings divided by the number of elements in our universal set. So we said then that P of k is the exact same thing as N of k divided by the number of elements in U, and we know that this is 4 over 54. Now, take a look at the situation here. This is what conditional probability says. It says, what is the probability of choosing a king? Notice it's exactly the same thing as originally in our simple probability example, but a condition is given. It says, given that it is a diamond. So what that means then is that we're actually placing a condition on the probability, which is why we're calling this conditional probability. And that will there be. That is going to be the condition. Now, how do you go about writing this? Well, we already know how to write what is the probability of choosing a king, what is the probability of a king, and that's just going to simply look like this. Now, how are you going to distinguish between conditional probability and simple probability? Well, the condition is given that it is a diamond. So what we're going to do then is, in order to note that, we're going to draw a straight line like that, and that means given that, okay, it is a diamond, and that's how we go ahead and note that we're dealing with conditional probability. Now, how do we go ahead and actually determine what this is? Now, if I go ahead and just think about what this is, it says, what is the probability of choosing a king? So I need to know that I'm choosing a king, but I know first of all that it is a diamond. So I know that I'm getting a diamond. So what that means then is that to a certain degree, I'm eliminating all the other cards except for the fact that I have only diamonds left. So out of all the diamonds, what's the probability of choosing the king? That's essentially the same result that this is actually giving us. So if we go ahead and take a look at that, of course, we know we have 13 diamonds. And in the 13 diamonds, we only have one king. So the probability should just be 1 out of 13. Now, if we wanted to go ahead and think about what that means, what we can do is we can just go ahead and use the formula, and this is what the formula says. If you have conditional probability, it is the probability of K and D divided by the probability of D. Okay, so let's go ahead and just think about what that means first. If we go ahead and think about the probability of K and D, well, that's the probability of K and D, that's right over here. That's 1 over 54. That's 1 over 54. And what is the probability of actually getting a diamond? Well, that's going to be 13 over 54. And sure enough, if we go ahead and simplify this, This is just going to be 1 out of 13. So that's how we can simply calculate a problem dealing with conditional probability. And the general formula that we're going to use is this right here. We take the probability of A given B is going to be equal to the probability of A intersect B divided by the probability of B. Okay, in addition to that, if we go ahead and multiply both sides by the probability of B, we actually get a nice way of expressing the probability of A intersect B, and that's the same thing as the probability of A given B times it by the probability of B. Okay, so given the fact that we can now go ahead and use Venn diagrams, being that what we're doing is we're counting how many things there are, then we can then go ahead and use those properties to go ahead and show a couple of laws of probability. One of them is how to determine the probability of A union B. Also, how to determine the probability based upon the number of elements within the sets. And also how to calculate conditional probability with the probability of A given B. Okay, so there you go. That's section 18I, the laws of probability. Let's see how you guys can do. Alright, I'll see you later. Bye-bye.